Hello everyone, welcome to Rubber Industry NewsHour. Sawadee krap, namaskaram. Welcome you all for this weekly program for the rubber industry on every Monday. We are on the episode number 17. Today date is 9th May. Welcome you all for this episode. As you know, this program, Rubber Industry NewsHour, is owned and managed by Technobase. Technobase is a company based in Thailand, established in 2005. It is recognized as International Resource Center for the industries and technologies. Of course, rubber industry is one of the main segment that we offer services. I do encourage you to visit our website, technobase.org, for more information. Today, I'd like to introduce you about one of the training programs which we have, rubber industry online training program. Technobase is one of the specialized organization which offers online training program for the rubber industry. Let me show you a short presentation on what kind of topics are available under this program. You can download that complete document in handout section. It's in PDF copies available there. You can see the list of the topics. Okay, let me run the presentation. Okay, that's our online programs. I believe that is very exhaustive, and yes, we have developed a huge resource for the rubber industry online program. So I do want to show all of you what kind of topics are available for the rubber industry. Please check our website, knowhow-webinars.com. Okay, let's get into our today's episode, Rubber Industry News Hour. Let me give you quick highlights about what we are including in this session today. First, we'll have a natural rubber market review by Mr. Jom Jacob, rubber industry analyst. After that, we will be having a detailed discussion called rubber industry panel discussion, focusing on the rubber testing, good and bad practices. We have 4 experienced rubber technologists and professionals with huge experience: Dr. Rodgers, Dr. Chrtistopher Robertson, Dr. Rajganesh, Jagadeesan, Dr. Samar, Bandyopadhyay. They will be discussing about what are good and bad practices in rubber testing. As you know, most of the programs on the Rubber Industry News Server will be available on YouTube at the Technology channel. If you miss any of the episodes, you can check the Technology channel on YouTube. Okay. So let's get to the rubber industry market review. Natural rubber market review by Mr. Jom Jacob. Let me introduce Mr. Jom Jacob. He is an independent analyst in global rubber industry with more than 30 years experience in analyzing rubber market, forecasting industry trends, and formulating long-term policies and development plans for natural rubber sector. He served the Association of Natural Rubber Producing Countries, we shortly call ANRPC, based in Kuala Lumpur, as its a senior economist for 11 years. And before that, he was with the Rubber Board of India by holding various positions for 23 years. Mr. Jom is a well-experienced rubber industry analyst for natural rubber. So let's welcome Mr. Jom Jacob.
Hey all, welcome to the natural rubber market review. So let us have a quick review of what happened in the markets in terms of price trends during last week. So today we have a table which is summarizing, consolidating the price trends in the major futures markets as well as physical markets. So first we will discuss how the prices perform in the futures markets. In the Shanghai Futures Exchange, prices averaged 1.0% higher during last week compared to a week before. Last week, I mean the week ended 6th of May. So the price during the week ended 6th of May was 12,853. That is 1.0% higher compared to a week before. So we should recall that when we presented the market review last week, we made an observation at the end. So we specifically mentioned that prices are not going to rebound in the short term, and we are not expecting a major fall in the prices in the short term because prices are already at the rock bottom level. So prices have limited space to go further down, and at the same time there is no scope for market to recover. This was observation we made. And also we specifically mentioned that prices can go sideways. That means it can marginally down or marginally up without any major change. That was observation we made regarding the price trends. So as we expected, price increased to 1.0%, which is marginally higher. That means that there is no much major change. Coming to psycho markets, I mean the most active contract, that is a contract expiring July, averaged 0.5% during last week compared to a week before. At the Japan Osaka RSS3 prices, I mean the October contract, which is the most traded on in terms of volume. So Osaka RSS3 averaged 1.3% higher compared to a week before. So this is a summary of what happened in the futures market. Coming to physical market at the right side of the same slide, we have STR prices, or maybe we can say TSR prices. Around 70% of the global trade in rubber is in the form of TSR. So we have two important markets for TSR. One is STR20 at Bangkok, and the other is SMR20 at Kuala Lumpur. So STR20 at Bangkok averaged 0.4% lower compared to a week before. That is a marginally lower compared to a week before. SMR20 Kuala Lumpur averaged 0.3% higher compared to a week before. That means marginally higher. And coming to RSS markets, we have two important markets. One is RSS3 in Bangkok, and the other is RSS4 in Kottayam market in India. In RSS in Bangkok market, RSS averaged 0.8% higher. That means marginally higher compared to a week before. But at Kottayam market, RSS4 averaged 2.7% higher compared to a week before. That means this increase is not marginal, a bit substantial, because this is largely due to the short supply, because of the hot climates in Kerala. The production has been affected, so that could be one reason. And coming to the latex market, we have two important markets. One is latex market in Bangkok, the other market is the latex market in Kuala Lumpur. And in Bangkok markets, prices average 1.3% higher compared to a week before, but in Kuala Lumpur, latex price averaged 0.3% higher compared to a week before. So this is the summary of the price trend during last week. And we had to take into account that last week, during most of the days, markets remained closed due to holidays. Holiday for the Eid, as well as holiday for the May Day, and Thailand had another holiday, local holiday. So that means the market were closed during last week. Most of the days, markets were open only for 2 or 3 days. And in the case of Osaka market was open only for 1 day. It was because it was a golden week holiday. So this was a summary of the price trend. Now we will see another slide which is summarizing how the market is performing right now. So we have seen the price trends and what are the undercurrents of the prevailing markets trends. First of all, we have to consider that futures markets are dominated by negative sentiments. When I say negative sentiments, it means speculative traders are staying on the sidelines due to negative sentiment caused by several factors. These factors include the continuing COVID lockdown in several parts of China, Russia-Ukraine war, and the massive economic sanctions announced on Russia, and the worsened global supply chain disruptions. So these are having negative implications on the global manufacturing activities. Disrupted supply, overheated inflation, and escalated raw material prices are impacting on the global manufacturing sector. And also there is a fear of aggressive interest rate hike by the US Federal Reserve, because in the next meeting of the June meeting of the FOMC, Federal Open Market Committee meeting of the US Federal Reserve, investors fear that the Federal Reserve may go for an aggressive policy hike to tame the overheated inflation. So that also is another factor keeping the speculative investors away from speculative riskier assets. So in short, we can say that business sentiment is dominated by volatility, uncertainty, complexity, and ambiguity. This is what is happening in the markets as well as business world around the globe. So this is why speculative traders are largely staying away from the markets. Now we should consider what is happening in the the second factor is what is happening in the demand supply fundamental. First, we will look what is happening in the demand side. We have seen just now discuss what is happening in the global business scenario. For example, the Ukraine-Russia war, as well as the lockdown in China. So around 70% of the demand for natural rubber comes from auto tire and auto component manufacturing industry. Around 75% of the global demand for natural rubber is coming from this industry. And also, China is accounting for nearly 43% of the global demand for natural rubber. So various factors we mentioned above are impacting on the global economic recovery, particularly the automobile industry, and also China is under lockdown. That means the prevailing situation can have a major negative impact on the global demand prospects for natural rubber. So the prevailing conditions, whatever we mentioned earlier, are having a major negative impact on the demand prospects for natural rubber. Now we will be that is what is happening in the case of demand side. Then what is going on in the supply side? Supply side, when we look at the supply side, the global supply of natural rubber is set to improve substantially from the beginning of May. This is because wintering off season. So we have a chart here to show what is happening in the global supply side. We have a chart here. So this is a chart showing the annual supply in a year. So it's total annual global supply. That's the share of the 12 months in a year. That means seasonal. This is showing the seasonal distribution of supply. So if the total supply in a year is split into 12 months, how it is distributed? This is showing the percentage share. So this is April and this is May, and this is June, July. That means starting from April, we are expecting a substantial improvement in the global supply of natural rubber from the beginning of May, because wintering off season of supply has ended and farmers have resumed harvesting or tapping in major producing countries. This is what we have seen from the chart now. And we have to consider what is happening in the supply in the case of China. China is a major consuming country, accounting 43% of world demand. And in China, China is a major producer as well. China is the fourth largest producer of natural rubber as well. And in China, the domestic production of natural rubber usually returns to normal by the beginning of May. So after remaining negligibly low for 5 consecutive months from December to April. From December to April, China's production is negligibly small, near zero. But from May onwards, China's domestic production is going up, is substantially going up or coming back to normal. That means that China has more domestic availability of natural rubber. Or we can say that China need not import too much quantity because China has a domestic supply. So China, or I would like to say China will be importing less because of the higher domestic supply. So that means the demand supply fundamental is likely to, is at the moment remaining unfavorable, and the demand supply fundamental is likely to stay unfavorable until China lockdowns are lifted, because China lockdown is having a major negative impact on the global demand for natural rubber. Because as we mentioned earlier, China is accounting 43% of the global demand. So China is under lockdown. Until China's lockdowns are lifted, the demand prospects will be weighed down. Then another thing, ceasefire should be reached between Russia and Ukraine. Until that happens, demand prospects and will be weighed down because of the supply disruptions. I mean, the manufacturing industry is not getting adequate raw material and component, and that disrupted global supply chain will keep demand side down if the war situation is continuing. Then another major factor impacting on the impacting on the rubber prices is the strong dollar. Strong dollar, I mean, so the rubber demand supply fundamentals. I would like to repeat, the prevailing strong dollar and the weak currencies of major rubber exporting countries can weigh on natural rubber prices. This is because when the dollar is strong, rubber exporters in the Southeast Asian countries will be getting an extra space to offer the offer natural rubber at a lower price. So whenever the local currency is weak or dollar is strong, exporters are more price competitive. Say they have an extra space to offer rubber at a lower prices. And this is what is happening in the rubber market as of now. That means the prevailing demand supply condition is not favorable, and this situation is likely to continue until two conditions are met. One is China lockdown should be lifted. Second condition, ceasefire should be reached between Russia and Ukraine. Until that, demand supply situation will remain unfavorable for the natural rubber market. Second thing, sentiment remain negative in the markets, and that is keeping speculative investors away. That means non-fundamental factors are also remaining unfavorable. That is largely due to the fear of aggressive policy rates by the US Federal Reserve and a set of other factors. That means in the short term, we are not expecting a recovery in the rubber prices. At the same time, we can expect little bit prices going little bit down because the continuing lockdown and the continuing Ukraine-Russia war are actually keeping sentiment down, as well as keeping the demand prospects down. So that means in the short term, we are not expecting a recovery in prices. At the same time, there are possibilities of prices going down a little bit in the short term. So that's all for the market review. Thank you very much. We will see you again next week at the same time. Thank you.
Okay, that's about the natural rubber market review by Mr. John Jacob. I'd like to introduce about some of his activities other than this weekly program. He's giving a masterclass on the natural rubber economics. It's scheduled on 15th June. Please check the details on the at knowhow-webinars.com. We have other program with John Jacob together. It is called the monthly program, the NR Dialogue, focusing on the natural rubber industry with various regions and markets. Next episode, which is scheduled on the 26th May, focusing on the Philippines natural rubber. We have three eminent rubber industry professionals from Philippines are joining this session, sharing their experience and inputs on the Philippine natural rubber industry. I welcome you all for this NR Dialogue if you're interested in the natural rubber market. Let me introduce you some of the rubber industry upcoming events for you to participate in important events. First, I'd like to introduce anyone in Singapore. There is World Rubber Summit, which is organized by the International Rubber Study Group, shortly called IRSG. They are doing this World Rubber Summit on the 24th to 26th May. Please check the details at the rubberstudy.org. And there is an exhibition in Malaysia, International Rubber Industry Convention Expo, scheduled during the 6th to 8th September in Kuala Lumpur. Please check the details. I welcome you all to participate in the Malaysian Rubber Expo. And I'd like to introduce about an event in India. IRC 2022 is organized by the Indian Rubber Institute, scheduled during the 24th to 26th November in Bangalore, India. Let me show you a short presentation on the IRC 2022. That's about IRC 2022. I welcome you all to participate in this International Rubber Conference and Exhibition in Bangalore. I also introduce about our exhibitions organized by Technobase. We have this GRTE Global Rubber Latex and Tire Expo, which is scheduled next year, 29th to 31st March in Bangkok. And we also have an exhibition, Arab Rubber Expo, organized by the Technobase in October 2023 in Sharjah, near to Dubai, in United Arab Emirates. I welcome you all to join these events. Okay, now we're into one of the key program today is the rubber industry panel discussion. Rubber industry panel discussion today is focusing on the rubber testing, good and bad practices. This is a very important subject for all the companies in whether you're producing any part of parts, rubber parts. If you have a good practices, you have better control on the quality, and eventually sustain your business. We have 4 experts who have extensive experience in the rubber processing, rubber testing. They've been seen day in, day out for many, many years about various issues about rubber testing. They will be discussing about what are the good practices, what are the bad practices. Okay, how to keep your testing programs proper. I'd like to introduce our panelist. First, let me introduce our first panelist, Dr. Brendan Rodgers. Brendan has spent 42 years working in the tire and rubber industry with both Goodyear and also ExxonMobil. He has worked on a broad range of tire industrial rubber products. He had worked in the United States, China, Ireland, Italy, Luxembourg, working on the original equipment, automobile tires, truck tires, industrial rubber products, and also the new tire materials technologies. He wrote 2 well-known books, Rubber Compounding, Chemistry and Applications, and also Tire Engineering, both published by CRC Press. So Dr. Brendan is well experienced. He is a good to all of us that he joined us as a panelist. Dr. Brendan, welcome. And his books, as I mentioned to you, and if you're interested in these books, you can check CRC Press website. You can order. These are well-known books, very useful books. Okay. Dr. Brendan, please open your camera.
Okay.
Welcome, Dr. Brendan.
Got it.
Let me introduce our second panelist, Dr. Chrtistopher Robertson. He is an international authority on polymer science and rubber compounding performance. He is a principal R&D consultant at Polymer Technology Services, which offers technical consulting and training for the tire and rubber industry. He has more than 20 years experience as a material engineer and technical manager in the tire, synthetic rubber, and plastic industries. He has worked with major companies Bridgestone, Cooper Tire, ExxonMobil, Eastman Chemical, and Endurica. And also he is a co-inventor of 34 patents and co-author of 68 publications in peer-reviewed journals with a citation high H-index of 34. And I'm very pleased to say he is the editor-in-chief of the scientific journal, Rubber Chemistry and Technology. I encourage every rubber technologist to read this journal, Rubber Chemistry and Technology. Dr. Chris, welcome.
Thank you for the nice introduction. I'm happy to be here.
Thank you. I'll introduce our next panelist, Dr. Samar Bandyopadhyay. He is also well-experienced, well-known rubber technologist who specializes in the rubber and tire compounding, material selection and testing with more than 30 years experience. He currently is working as a business head in Pukhraj Additives, a rubber chemical additives company. He's also lead assessor of National Accreditation Board of Testing and Calibration Laboratories. It's called NABL in the field of testing and proficiency test program. He has assessed more than 300 labs. He's also guest faculty in India in the polymer science and technology. He's also currently a Secretary General of Indian Rubber Institute, which is a prestigious and a professional society of rubber technologists. He also contributed more than 60 papers and 3 book chapters. Dr. Samar, welcome on board.
Thank you for your nice introduction.
Welcome. Let's invite our last panelist today, Dr. Rajganesh Jagadeesan. He has more than 15 years experience in the field of polymer materials characterization techniques and their processing techniques. His major expertise in the study of the structure-prop relationships of the polymeric materials, processing relevant material characterization, material property correlation with processing behaviors, and also the processing related modeling and simulation techniques. Currently, he's working with TA Instruments, a division of Waters in India, as an application support manager for the last 9 years. Dr. Rajganesh, welcome.
Hello, everyone. Thanks for a nice introduction, Aaron. It'll be a pleasure to be part of this panel discussion.
Okay, guys, welcome you all. I'm very excited to host this panel discussion on the rubber testing, good and bad practices. Let me give you some agenda for today discussion. First of all, this discussion it's like a coffee table discussion. Okay, it's like we're all having coffee together. Okay, I bring my coffee cup now. Okay, so yeah. Okay, so I welcome you. Having a coffee discussion on the important issues about rubber testing, good and bad practices. Just give you some. Let me make you some ground rules or ground for this, all of you, for the discussion. This discussion is not just only for the people working in the laboratory, but also management as well. They should understand what are the good practices and bad practices, so that they have a better control on the quality of their products. At the same time, they utilize their resources efficiently in terms of product development, or maybe reducing the defects in a number of ways. So, and what I'm going to touch is that what I would request all of you to discuss is the, okay, there will be, these are the points I'd like to address it. Maybe we go one by one. One is the testing methods, sample preparation, measurement accuracy, data management, data interpretation, but also the instruments, and also how you have to maintain it and selecting the right equipment. And so on product, it's a broad. I know we can talk a whole day on these issues. Within the time what we have today, we try to address appropriately, on this point. Okay, so all are okay with this? Are good? Okay, super. Okay, Chris, I wanted to get started. I think I want to give the ball to you first on the testing methods. After that, we'll go one by one, all other panelists as well. Hello, Chris.
Yes, thanks for letting me kick this off. I was thinking a little bit about rubber testing and wanted to just hit on a couple of basic things to get things moving. I guess the first thing that comes to mind is why do we do rubber testing? And I think there are a lot of reasons, but there's 2 main reasons. One is quality control. Rubber compounds are very complicated. We have polymers, we have several fillers, curatives, process aids. There could be 15 ingredients in a rubber compound that all come together in 5 minutes in a mixer or less. And so we want to make sure the raw material that we're getting is still the same. That's part of it, and also the final compound hasn't changed. For quality control, it's no problem to take the rubber, cure it up into some sort of shape, and make very, very simple geometry and test it. And for that reason, testing is very effective, and we have a variety of ASTM tests that I'll get into just briefly later. But there's another aspect of rubber testing, and that's, we make these rubber products, right? This is some kind of bushing. Most of my background, and then Brendan quite a bit of time too, was in the tire space. And this simple geometry, while it's fine that knowing that this compound hasn't changed batch to batch. What does it tell you about what's going on right here in the rubber compound when this tire is going down the road, right? So and that's a more complicated discussion of rubber testing. So if you could share my slides, Param.
Okay, give us.
I just put together a couple of slides just to help move the discussion a little bit. And of course, I have to take the opportunity to get some free marketing. So thank you for the nice introduction already. If you're interested in knowing more, my website's there, Consulting for Polymers. So please check it out when you get a chance, if you need any help in that area. If you could go to the next one. So I was thinking of just a couple of do's and don'ts to get things rolling. It's only a few slides, and after that, I think we can have a pretty good open discussion. What I would say is, you know, for reasons of consistency and being able to speak the same language as your supplier and as your customer, ASTM tests are very important. They make sure that people in different locations all around the world, we're a global industry, they're doing things the same way, so that when they share results, they have an idea of what they're talking about. And so I think these tests are very important, and we don't want to certainly get rid of these tests. They're very essential to the rubber industry on the one hand, right? They're very important in particular for that first category, right? For the quality control side of the rubber testing. But what these tests do not do, and that's the sort of the don't, is don't use these tests as some sort of measure of what's going to happen in the field to the rubber product. If you could skip to the next slide, Param. The one that stands out to me the most is tear. I've spent quite a bit of time with failure of rubber, and we should just be a little bit careful whenever we do tear testing. It turns out there's a variety of geometries that can be used, and these are all in the ASTM standard. So ASTM standards are good on the one side. They give us a framework, but there's a lot of variation within the framework. And so I think, you know, I would say use the ASTM standards, but be cautious. And the one example I always use, because I think it's the most obvious one, is when it comes to tear testing of rubber, almost every rubber lab I've ever visited or worked for really likes the die-seed tear test. But if you know what tear is about, tear is when you put a really big crack with scissors or a razor blade or a nick in the specimen, and then you see what happens to the rubber when you start to load up that big crack. And what you'll see with the die-seed geometry is, in fact, there is no cut, there's no nick. In fact, it has a lot to do with how sharp your die is when you cut out this sample. So I guess what I would say is, if you say you're going to do tear testing according to ASTM, and you pick the trouser test, the type T, fine. Die B, fine. If you don't have much material, die A is a kind of a small die B sample. Those all actually are tear tests. But the funny thing is, the one that's the most popular is in fact the one that's not even a tear test. And so I would say use the ASTM test, but just be cautious about whether they're really reflecting what you're trying to measure. Next slide, please. And then just the other thing I'll talk about in this context is the way we use rubber is generally in fatigue. But the most popular test in the rubber lab is definitely the tensile test, right? We just take a piece of rubber, load it up, we keep stretching it until it breaks. But we never use rubber like that, right? There's very few single-use rubber applications. So why is that? Why is the most popular test not the way that we use rubber? It's simply because efficiency, right? We can get a lot of information from this very quick tensile test, but this is a single pull. It's one cycle failure. When we use rubber, tire, bushings, all kinds of applications. Those are all fatigue applications. So I would, this gets to that second one. If you're trying to predict performance of what's happening in rubber, you know, sometimes the ASTM tests that we use the most, like the tensile test, don't tell you what you really would like to know. So there's kind of two uses of testing methods. There's one that tells you that the rubber is not changing, and then there's another test that tries to get a little bit predictive of what's going to happen in the field. And then the only other thing that I had formally to discuss, Param, if you could go back to my second slide. The slide number 2, I think. Yeah. We used to joke about this. It's okay if you add a rubber test to the rubber lab, but it's almost impossible, nearly impossible, to remove another test. And maybe you know, the example that comes to my mind, and maybe Rajganesh can speak to it because of TA Instruments, is we have very modern equipment nowadays for testing the viscoelastic properties of rubber, and yet in that same lab where you have this, you know, very nice, expensive, you know, high-powered DMA, people are still taking these rubber discs, tearing them, and bouncing a pendulum off of it. And so it's certainly the viscoelastic measurements that you get from the DMA are making this test redundant. And so there's a danger. If we just keep adding rubber tests to the lab, now your efficiency is going away. There's a lot of confusion too, right? If you have too many ways of measuring rubber. I'm not saying that the rebound test is not valuable. Maybe somebody 20 years ago had a good correlation to something in the field. But I would just, this is just a suggestion that, you know, definitely consider adding new capabilities. We want to be a modern, evolving industry. But if we just keep adding and not subtracting and removing redundant tests, I guess that's just my my input, is to just sometimes go through and take a look at what you're doing and ask, you know, do I really need this test anymore? Right.
Thank you, Chris. That's good points addressed. Brendan, over to you.
Oh yeah. Okay. Yeah, I certainly agree with almost everything that Chris has said. Particularly, this kind of resonated with me on the tear testing, because there has been a lot of labs do prefer the DIC and the ASTM with 624, I think is the ASTM number. And you know, the reasons for that are probably the wrong reason. Like, for example, it's easy to die out a DIC dumbbell and do the test. But when you start adding a nick or a cut, then you're adding labor. There's an extra piece of equipment, and then there's the quality of that cut. It's like a millimeter or whatever. I can't remember what the depth was, but and that adds labor. So when we look at the lab management, when they look at these things, they see cost, they tend to take the shortcut, and that's what is happening here. I would argue the DIC is certainly a more predictive tear rather than the DIC, which is more of a modulus indicator. So, and when you look at a tire, sort of like a truck tire, that was a good sample that you showed there, that cross section. In North American service, when you're looking at an 18-wheeler, like the steer axle tire, it's loaded up with around, the axle's got 6 to 7 tons. And on the US interstates, those vehicles are running at 120 kilometers an hour, sometimes faster. In the summer, it's hot. So the durability, adhesion, the tear resistance of the compounds become of paramount importance. And when we take shortcuts in the lab, then we miss this predictive element. I certainly agree with what you said, Chris, about the not using these tests as predictive tools. And although you can't, you know, there are models which show that, you know, there are some, you can't predict some things, but it's a dangerous path to go along without a large database to support you know, the relationship between the lab data and what's going to happen on the road. And that brings up another point, and I kind of wrestled with this one fairly recently. We see, and certainly with some of the some companies, they look at the labs as a cost center, and they want to try and manage that. And certainly in North America, which is a very, very competitive market, there's a lot of downward pressure on pricing, a lot of downward pressure on net product pricing. So, how can they contain costs? So in the lab itself, lab work tends to get outsourced to a third-party lab, and North America, we'll see several labs have emerged in the last number of years to provide that third-party service. So the major tire companies can then cut back on their lab budgets, lab commitment. And again, I think that's a dangerous path to pursue. It's certainly good for the third-party organizations, but when you lose control of your lab work, your lab resources, then there's a risk associated with that. So one thing I've learned from experience is you can never have enough data when launching a new product. You can never have enough data, and when the lab resources tend to get trimmed back somewhat, then again, it's a dangerous path. It might take 5 or 6 or 7 years for something to happen, but if there's a recall occurs, that can be extremely expensive and negate any savings that have been generated through cutting back on R&D resources or lab resources, not just the rubber compounding lab, but also the tire testing labs, both the indoor wheel testing and of course the test track resources as well, and field testing. So the lab is certainly very crucial, and it's got to be it's got to be the resources got to be enough to support the business. Again, the outsourcing is a dangerous path to pursue. On the test methods specifically, I agree with everything Chris said. The ASTM test methods are very well documented. They're global. On the ISO, when ISO emerged in the 80s and 90s, we're very much an adoption of the ASTM and British BSI, British Standards Institute, and then the German DIN, very much a consolidation of those three organizations into a global ISO standard set of test portfolios. But certainly the ASTM methods, they're the oldest, well documented, and they provide a good framework for conducting the test itself. And then we have the other thing in the background as well, not the ISO QS 9000, TS 16949 test methods, well, not test methods, but more procedures on how to manage labs, how to manage your test method portfolio, and so on. That's all fine. One thing I did find though, we have ASTM, ISO, we have the international standards like ISO 9000, the QS and the TS standards. But when I had the opportunity to run a lab, I found the most effective way of getting the quality of the lab up was going after individual standards set by customers such as, well, back in the day, it was the British Defense Department. To get qualified, a lab qualification from an organization such as the DoD, those standards are exceptionally high. And if you can get there, you are running a really good quality lab operation. So those organizations such as the DoD or the Department of Energy here in the US and so on, you can get their qualification, you get their certification, you're in good shape. And that drills into all those details on what Chris alluded to on the test methods, the details of the test methods and what they mean and so on. So I think I see more the some of the other issues in addition to the methods themselves is things like ensuring there's adequate resources to support the product portfolio of the company or the research institute, and that's been the biggest issue I've come across recently, is making sure we've got enough resources. You can never have enough data.
Yes. Okay, Dr. Samar. Thank you, Dr. Brenda. Samar, yeah, your experience in India.
Thanks, Chris and Brendan both. Chris has given very nice some samples shown to the presentation, and he also told about this DIC and DIE type of tensile samples are also there. DIE, which is the smaller one, that is for preparation of sample from the tire. This we have experienced. That is a smaller tensile dumbbell, which is having slightly lower thickness, and also the shape is smaller. So this material is also, we can do the tensile testing other than the DIC. DIC, in that case, our experience is saying DIC and DIE is well correlated. And if we can, DIC we cannot make from the products because that much dimension we don't get. But DIE, if we make, and if we correlate with the compound of that particular product, there is a good correlation that we noticed over the 20-25 years of experience. And what Brendan told, ASTM is a fantastic test methodology. And ISO came later, much later. ASTM, I started my career in 1992. And that time, this JK group of organization, they were in collaboration with General Tire USA. And since General Tire, we came across mostly with these ASTM standards. And later on, this General Tire was taken over by Continental. Continental being a German, they preferred for ISO because ISO standard, particularly their standard was DIN, and later on they told it is better to go for ISO. So both ASTM and ISO experience we got from both the tire manufacturers as a collaborator. Later on, JK Group, they discontinued the collaboration with Continental, and they are now, they have established their own technology. And laboratory, what we got, that General Tire is a fantastic material and compound, as far as compound and material is involved. They are fantastic. And everything is so systematically given in the, like in tensile dumbbell. I have seen in many laboratories through my assessment experience, many people are not knowing what is the thickness to be kept. Some people are keeping 3 millimeter, the tensile dumbbell thickness. The thickness should be 2 plus minus 0.2 mm. And what is the significance of that? Many people, they don't understand. And suppose the hardness, 6 mm thickness to be kept for hardness. People sometimes they pile up the tensile dumbbell and make 6 mm, or they make a block like the rebound resilience sample what Chris shown. That type of button sample is made, and then the hardness is measured, like your IRHD or the SORE. And this SORE and IRHD, very funny. You know, SORE, many people, as per their own strength, they can measure the hardness. SORE, some stout man, he can measure SORE more. And a feeble, weak person, he can make SORE less. So that error is eliminated if we go for IRHD, International Rubber Hardness Degree, which is a constant. And nowadays also SORE with constant load device is available in the laboratory. So constant load SORE will be better. But the pocket SORE device, which we can take anywhere, and we can measure the hardness of the product as well. So that can be some error is involved in that, depending on the means person to person variation. And again, the tensile dumbbell preparation, the particular mold size and the press dimension and the pressure that to be given, very, very important. Otherwise, if some more pressure or less pressure is given, thickness variation happens. And the mold cannot take care of the thickness part. So this we learned over the years. And one more thing in the this grip, tensile grip, some of the samples they slip because of their high tensile strength. They slip, and if your grip is not proper, in that case, you will get a erroneous result. Sometimes we experience that we have to grip with the help of some MRE paper at the grip. And if we are not holding properly, there may be chances of slip, and we don't get any result. If the sample slips, you are gone. And if you are having calculative sample, then those data cannot be taken. So these are some of my experience over the years.
Thank you, Dr. Samar. Raj, how is your experience?
Sure. I completely agree with my previous panelists, what they were giving the excellent input about the test method and the test standards. I just want to add on a few points about the instrumentation aspect, what we need to look into that. If we coming to the any instrumentations, like one of the key aspect is how accurately that instrument is going to perform a test. But there are three factors which influence that. One is the instrument itself, that is defined by the instrument's performance criteria. Okay. And second thing is about the operators. So like Dr. Samar was explaining how sample is being loaded on that particular instrument, that also matters, because many times we have to, when, for example, Dr. Chris was talking about DMA, and DMA today is being very widely used to understand the viscoelastic property of a rubber material. So, and we have different grips which is available. Sometimes we call it a clamps like tension, compression, and shear, all those things. And each grip would need a special approach. So you have to prepare the test specimen, which can be used for that particular analysis. And that specimen preparation is very, very important. Like I've seen many times customers make some mistakes, like if a customer wants to work with a tension grade, what they do is they take that molded sheet and just with a scissor they cut the specimen. Okay, so that's not the correct approach, and you can see clearly when you use the scissors, you have the cross. Okay, and that is going to vary your width and thickness of that particular specimen, which is ultimately going to affect your result. And we any DMA analysis, you are the operator has to enter the dimensions, and there they have to give the accurate dimensions. If you are entering the wrong dimensions, and all your results are going to be wrong, because the DMA is simply going to measure the stiffness, not the modulus. The modulus is calculated based on the measurement what we are performing it. So that how accurately you are giving the dimensions is very, very important. Okay, so that's the first aspect. So that's where I said the operator's role is very, very important here. How accurately he is preparing the specimen, and then second thing is a loading. So now we take the specimen and then loading on the particular clamps, where you need to tighten the clamps at the proper torque. So if you are not tightening it properly, or if in case you are over tightening, so you are already deforming the samples, which is not preferable. And second thing is, we also account the stiffness of your clamp, because as any DMA, since we are talking about the DMAs, basically the DMA is going to apply the force and then measure the response of the sample as a deformation. So from the force, we calculate the stress, and then the response is the deformation. We calculate the strain. So once we measure the stress and strain, we can able to calculate the modulus. So that's how it is working. But in dynamic mechanical analysis, we would be applying the stress and strain in a sinusoidal fashion, and that is the reason we get that in how the response with respect to time, how the response to the samples, that we measure as a phase lag. So if you know this, by doing the Fourier transformations, we get those viscoelastics modulus like storage modulus, loss modulus, and tan delta. These are the particular important material parameters. Okay, but here all these are calculated variables. This is not measured directly. The absolute quantities are like force, the deformations, and that's where the instrumentation side. When before selecting a particular instrument, you should be clear on how the instrument is going to measure the force. There are multiple various types of DMAs available in the market, as you know. You have the force control DMA, strain control DMA. So if you look at the force control DMA, so basically the actuators apply the force, and the response, which is the deformation, will be measured by the particular sensor, that is optical encoder or LVDT. Those kind of transducers being measured to measure the strain. So before selecting such equipment, you need to be understanding better how the particular DMA instrument is going to apply the force, what is the force range, how much of force resolution. These are some of the key selection parameters before choosing your particular equipment for your applications. In common in rubber industry, people prefer a high force DMA rather than the low force range. High force DMA means I'm talking about the force range of between 500 Newton to 1000 Newton. That's a common force range what people prefer, because rubber materials are stiffer as compared to normal thermoplastics kind of materials. So they always prefer to work with a high force DMA. But we should also understand the limitation of working with high force DMA. Okay, so you may have the limitations, which we will discuss more in depth further. But what I'm saying, as a selections, first you should know how the parameters are measured and what is its accuracy, what is the resolution patterns. Those kind of things is very crucial. And second thing is, like I said, we are using a metallic grips. So we should also understand how stiff those clamps grips are. Because when you apply the highest force, we can say, okay, you are commanding certain highest force, but whether the instrument is going to apply that. So that is the first part. Second thing is whether my clamp is stable enough, is stiff enough to withstand that force, because that is also have a compliances. So one should be familiar with the compliance of the particular clamp that what we be using it. So that is the second aspect. Okay, and third aspect is the temperature control, because most of these DMAs are performed under the temperature varying conditions, I mean non-isothermal conditions. And we all know that rubbers are basically very slow thermal conductors. So we should be aware what is the optimum temperature ramp rate or heating rate that we should use, because we should not want any thermal lag. So these are some of the key experimental aspects which one has to consider before designing the run, and then we can get the optimum data. So then the DMA is giving a complete flexibility, like various test modes. Like Chris pointed out, we can do dynamic studies, which will give you the result about the complete viscoelastic modulus as a function of frequency, time, temperature. So you can get the entire viscoelastic spectrum of your particular compound. Okay, and second wise, you can also do a transient test. What do you mean by transient test? Like we were talking about creep test. So where we can understand the creep recovery behavior of the particular rubber samples, that is possible. And then we have a stress relaxation test, that is also possible. And third is like you can use this kind of advanced DMA today as a fatigue testers. If you want to understand the durability of a particular compound, and that is possible, like you can establish your SN curve with that. So this is giving complete offerings, so you can have the modularity in terms methods. You can pick and choose depending on your application. So that's the main things. And there are many established ASTM, ISO, DIN standards are available, but I would only advise, because my previous panels was telling about, I mean, they were talking about how good these ASTM are documented. But what I'm adding to that, we also look for the revisions, because there are every time there was a revisions, and people need to get those updates and then look for what is the new amendment. Okay, so that is something you need to follow. So that's about from my side about this point.
Thank you, Raj. Chris, would like to add any additional point on this?
Yeah, very nice discussion. I'm enjoying listening to the panelists. Concerning DMA, we can kind of go along that line. I spent quite a bit of my career sitting in front of various types of rheometers and DMAs. The one thing that Rajganesh said that kind of resonated with me was about temperature control and knowing what temperature your sample actually is very common in the plastics industry, where you take a very thin film of plastic and you use DMA just to identify where the transitions are. You rarely use the G prime and G double prime for anything other than to identify where these transitions are happening. Now in rubber, we actually want those viscoelastic parameters. We use those for various reasons, for predicting heat buildup, for predicting performance in dynamic applications. And it's very common, especially in the tire part of the rubber industry, to not do temperature ramps, but to do a series of steps where you make a 2 degree or sometimes a 5 degree step. You let the instrument and the sample especially equilibrate, and then you make the measurement. And then you make another step and you let the sample equilibrate and you make another measurement. Now you have a temperature dependence because you get data points every 2 degrees. It's giving you similar data to what you would get with a ramp now, but you know at each temperature, at each condition, the sample is truly at that temperature. So I think that was a really good point that you brought up, that a lot of people don't really think about. The other one, it was kind of, I'm still, maybe this is an open question. I don't know where this comes from exactly, but in other areas of rubber, like hardness, like tensile testing, we've sort of accepted that there's some measurement variability. And so we test multiple samples, 3, 5 repeats. But on the analytical side and on the more towards the side of where the DSCs and the DMAs, and we're very happy running just one and saying it's done. And I don't know where that came from, except maybe that it's just an instrument utilization thing, right? DMA tests, especially if you do frequency and temperature together across a wide range, these tests can sometimes take 3 or 4 hours, and maybe it's just a practical thing that the bottleneck in testing just makes it so that you really can only afford to test sample one time. But it's just a caution. I mean, when you see people present data or you see data in a patent and it's coming from a DMA, it's possible and quite likely that that was one single run of the sample. And so it's kind of interesting to me that on the other hand, later I have a slide about tensile testing where I show you that sometimes you should test 50 repeats if you want to learn about failure statistics and reliability of rubber. And on the other extreme, for some of these dynamic tests, we're just testing one. It just kind of something to think about is maybe we ought to think about repeating when you do a cure curve on an MDR or an RPA. Do you do one or do you do multiples? I mean, I just think there's a tradition there that it's worth rethinking. That's my only comment.
Raj, you want to say something?
Yeah, I want to say, I completely agree what Dr. Krish is saying, because the confidence why we are running one sample is particularly to DMA. If you see the DMA, we basically run this DMA experiment many times in within the linear viscoelastic regions. So we are hardly going to damage the sample, unlike when you are doing a UTM test. And second thing is, we also do certain calibration of the instrument before we do even the test. So that's give a more confidence that even with a single sample you can do it, because it's not a destructive testings. So most often you choose the strain or the deformation level or the stress level within your linear viscoelastic regions, and that is what you would be doing at various frequencies or at a different temperature. That is important. But where people might make mistake is like how you rightly pointed out about the heating ramp. So like we have different approaches, like linear heating ramp, or you can have a temperature ramp, temperature sweep. So temperature sweep is something it's different. So I would always recommend my customers to use the temperature sweep rather than temperature ramp, because sweep, say every temperature you have the equilibration, and then you can perform the frequency sweep, collect the data. So it's given a more confident that the sample has reached that temperature, test temperature, and then you get the data point, and then moves to the desk temperature. So that would be the give them more confidence actually. Yeah.
Thank you, Ganesh. Brendan, would like to add some points?
Oh yeah, it's going to sound a bit repetitious, but certainly when it comes to DMA, DMTA testing, from my experience, there's probably the three big issues. And we have this dilemma of one sample tests, because like we do a temperature sweep in the lab, that could take up to 1 day to do a full do a temperature sweep from minus 80 degrees centigrade up to plus 80 to get the upper and lower boundaries. And that's a you tab a technician for a full day there, and if you've got 10 samples, 10 compounds to test, well, that's 2 weeks for one sample per compound. But I have found there's probably the three big things. Number one is the technician, the quality of the staff that use to do that test. You put your top guys in there, the most skilled top technicians are the ones that you have to use. You can't give this to just a general lab, the lab staff, and they're typically degreed people. They've got a degree of some form. In fact, I found some of the best technicians that for this type of testing have been former teachers, and they leave the teaching profession and join the lab. And I find they're diligent, thorough, well educated, and they understand the physics behind the test. So certainly the lab staff are crucial in terms of getting good data. And the second thing, and this is probably a bit more controversial, is the quality of the sample. Now, and this goes down to if we're taking samples from a factory and samples are mixed on an F370 or a 600-liter mixer, the homogeneity of that sample is open to discussion. For bulk samples. So if we're dealing with a small test specimen that's been extracted from a 200 kg batch, there's going to be a lot of variation in there. And we're dealing with a sensitive test like doing a temperature sweep. We're going to see variation, and it could lead to confusion in the data interpretation. So sample uniformity becomes crucial, particularly if we look at the R&D spectrum from basic research through to technology to implementation of a new product. Certainly, we need those fundamental data that's generated from a DMTA test, like the TA instruments. I'm a big advocate, fan of TA instruments, by the way. So the data there is crucial. When you get into the bulk samples that are going to go on a tire tread, for example, on an earth mover tire, there's so much non-uniformity within the compound that we need to be careful in using that data. And in fact, this is where I sometimes prefer the rebound test if we're looking at rolling resistance, because the bulk sample, we negate that non-uniformity to a large degree, to a degree, versus what we have for the tiny specimens in the DMTA. And in fact, when it comes to predicting rolling resistance specifically, there was a rebound test, the Goodyear-Healy rebound, and that used a big block. In terms of if we take 1,000 rolling resistance data points from 1,000 tires, which the big tire companies have, and then look at what correlates best with rolling resistance, certainly that you get good R-square numbers with the tan delta number, but that Goodyear-Healy rebound, from the data I've seen, always come at number one, and it was more a bulk phenomena. It was a bulk phenomena that was behind it. So, so you get the sample uniformity, and then so the operator sample uniformity, and then of course this ties into the operator as well. Making sure that the dimensions of the sample that go into the DMTA machine are accurately inputted, and any variation or any error in that data input can really end up getting misleading results when the technician reports that data. So from an operational perspective, again, that's DMTA, it's the operator, the sample uniformity, and making sure that the numbers are inputted correctly into the computer whenever they record the sample gauges and so on. That's been my experience more at the practical end. But in terms of DMTA as a predictive tool, there's no question about it. It's certainly a very effective, and new materials development is certainly a very effective tool. So,
yeah, please.
Shall I add here?
Yeah, go ahead.
Actually, DMA has come much of late compared to this your rebound resilience. And Brendan has rightly said, rebound sample is little bit more compared to the DMA one. And rebound is having good correlation with your dry traction, or even if you can make it 0° wet traction, or 70° rolling resistance and 100° Goodrich heat buildup. So we found that rebound has some good correlation with all this data, because that time this DMA was not there. I am talking about maybe 2000, before 2010. DMA might have come after 2010. Raj, you can correct me. When DMA was introduced?
Sir, that is there even 2019s also, but it was not very common in the industry. It is more of academic research, is like institutions was using that DMA approach. And if you look at that, even the previous DMA approach is more of like a transient method. Even to get the relaxation spectrum of polymeric material, they used to work with the grip and stress selection, because that time there is no dynamic motor available. Okay, but the recent like 90s is when we have this advanced dynamic motor, which can directly apply sinusoidal stress or strain onto the cell. So that's why. But it is there even late 90s also, but it was not common within the industry side. Actually, it's more of on the academic research. Yes.
And also the cost. Basically, the DMA is much costlier compared to this rebound machine. And but rebound is also has got good correlation with all this wet traction or rolling resistance, or even the Goodrich flexometer. And of late, when DMA came, as Chris said, whether we'll go for rebound as well as DMA, whether it is required, because DMA gives you much more information and maybe precise information. So then why we'll go for the rebound resilience? That also I agree with Chris, that whether we should go for everything or we should go specific. And very important is the skill of the people who will be operating the DMA. Definitely a dedicated person who is properly trained, and concentration. Basically, in this equipment, you require a lot of concentration and sincere approach. Otherwise, if you are moving here and there and do this will be some mistake. And that's why the skill, giving time, and dedicated people must be used in the DMA. That is my experience.
I want you guys to touch on this RPAs. Okay, Raj, you want to add? Yeah.
Actually, I just want to add about this point about the skill thing. So from the as a instrument suppliers, we understand these challenges very much. So what we do is that apart from designing the instruments, we also consider that like how skillful, because today if you see that the industry starts slowly moving to the DMA analysis, it is now become the standard testing protocols in most of the industries. Okay, so we also want to give the instruments to the personals in working in the industries to start operating without having a elaborate rheological knowledge, because that is not be, we cannot expect that from a standard QC lab. So what we do is we also design our software interface very user friendly, which have the interactive session like how to prepare the clamp, how to prepare the specimen, how to load the grip. So it is more of interactive. So every time he's doing any performance, any operation on the instrument, the software interface will guide them. So it will, it will reduce that kind of intensive training. So you don't need to, put the operator for a very long and intensive training. With a limited knowledge, he started working with the instruments. That is important from the industrial point. So we are working on it, and we even from rheology and DMA, we have the approach like having a very active interface, and that will guide the user throughout the operation of the instrument. And not only that, even the interpretations later, like as Chris and other panelists was telling. So we have the long test runs, right? So you have the huge data at the end of the test. So you need to generate you have to apply certain algorithm to get the master curve, all those things, which is by using time temperature superposition, which is going to be very elaborate. In our PhD time center, we used to do it by using Excel sheet. But today, your software has that features by default. So it's by just click and click, you will get the master curve. So, and then finally you get whatever the material constants. It's not that very complicated. So that is, we are working on it as an instrument supplier. We are working on it, and we make that very simplified to the operators. I just want to add on this point here.
Okay, thank you, Raj. I'd like you guys to touch on this RPAs, another popular equipment as well. Okay, Brendan, would like to touch your experience with RPAs?
Yeah, RPA is a very effective instrument, particularly in for manufacturing, for quality control. I find it's a lot better than. Let's go back 30 years ago. It was customary to do if you're doing like a 100 batch run for a wire coat compound in a big factory, and you sample the beginning, middle, and end of the run, tensile tests, MDR rheometer, and a Mooney. The RPA can replace all that. And you get more accurate data. It's also very effective at pinpointing trends in the factory quality. So if we have we're running a compound, we're going to have for a particular mechanical or chemical property, vulcanization, kinetics, whatever. We're going to have upper and lower limits for quality control, and the alert limits built sort of built in there as well. RPA is very good at flagging out when the compound starts to drift off the center of the spec, more effective than the other tests. So certainly it's very good. The only negative is the cost. To put in 10 RPA machines into a big factory is, there's a hurdle there. I can't remember what the exact price is, but something in the order of $150,000 per machine, and that's steep for a quality control machine. But I think this brings up another issue, and it's more in the long-term trends. So look at the management of the lab resources. I think the utopia, the ideal, is to be able to get to like a combinatorial approach to both compound development and when it comes to compound quality control, building neural networks. And I think that's going to be the long-term trend. That's what we'd like to get to. So RPA can be argued as a step towards getting to a combinatorial approach where you get a lot of data from one test and a lot of useful data from both vulcanization kinetics, process information, and some viscoelastic data on the cured sample. So there's a lot of things can come out of that. And the pharmaceutical industry has made some enormous strides in combinatorial approaches to drug development. You can argue the COVID-19 treatments, the tools that were used to enable those vaccines to develop so fast and so safely has been phenomenal. And the combinatorial approaches have used in the screening to get there so fast. Again, those folks deserve a Nobel Prize. But if we can sort of mimic that type of approach in rubber compound development and quality control technology, I think that's going to be something that would be great. And the RPA is a potential tool to help us move along that path. And then, of course, when it comes to neural networks, to move into those predictive tools would be great. And the thing about the RPA is building a neural network, the data quality is crucial. And to take existing data, there's a lot of scrubbing to the point where it can become prohibitive. But with an RPA, we have more, the data is more reliable in terms of what can be used in a neural network and building a neural network. So it's a very effective tool from all those perspectives. So that's kind of how I saw it. It's a useful tool today, and it could be a foundation for a lot of innovation in the future in terms of lab development, technology, and science.
Chris, what do you like? You have any additional points to add to on RPAs, Chris?
Yes, the first thing I would say is if I could just have one instrument, I would pick the RPA. In fact, I joke with people, if I could put one in my garage, I would have an RPA in my garage. And I just gave a presentation 2 weeks ago at the Rubber Division, and 90% of the data in that presentation was from an RPA. I like what Brendan said about using this towards combinatorial compounding, right? Or some sort of virtual compounding or predictive, because the one thing that the RPA offers is ease of sample prep and automation, right? You can imagine coming off the sheeter, a batch of rubber, you could easily imagine taking a piece of that, cutting a small sample, putting it on a belt, and that belt feeding right into the automation of an RPA. Let's not forget, the RPA is a type of DMA. We call them differently, but the operating principle is the same in a sense that we're doing an oscillatory measurement. But the nice thing about the RPA is you can test uncured properties, so you can gain some insights into processability. You can get rid of the Mooney viscometer. Hopefully, we keep talking about the RPA is going to, remove the Mooney viscometer, but people still hanging on to it. That's that initial discussion I said we ought to be having more. Is let's not hang on to things just because they've been there forever. Let's think about ways to, in a smart way, modernize and sort of streamline. RPA could easily replace the Mooney viscometer, but you can also, in an RPA, you can take that sample, take it up to cure, cool it back down. So in the same sample, you could put a piece of uncured rubber in, do a strain sweep to understand how well your filler was dispersed within your rubber compound, take that very same sample up to cure, look at the cure kinetics so you know everything looks okay there, take it, now it's cured, cool it back down in the RPA, and do another strain sweep or do some at different temperatures for predicting different performance of tires, for example, at 20 degrees, 50 degrees, 80 degrees, this kind of thing. And some of the RPAs now, just last year, Alpha Technologies lowered the temperature a little bit. Now you can get down to, let's say, -20. So you can start thinking about wet traction predictors, maybe snow traction possibly. So you have the ability in one sample to learn about how the material is processing in the plant, how it's curing, and also how it's going to perform in a cured state, and all while being able to feed a sample on a belt to an automated system or put it in a tray. If you've seen these automation systems like most of the RPA manufacturers have, where you can put a bunch of samples around the tray and it just automatically feeds. And so it is, I think Brendan's right. I think that's the next horizon, is how do we take all of this and make it happen quickly so we can do product development very quickly. And instead of testing 10 batches, right, we can now test 200 and quickly come to the ones that are the best. But also in a plant, maybe you don't need as many operators if a robot can cut a piece of rubber out of the sample, put it on a belt, and it goes straight to to an RPA. And if you've ever watched someone load a sample in a Mooney viscometer, you can't imagine how that could ever be automated. But if you watch an RPA, it's beautiful, right? You have the feeding systems and the films pull the sample, and it could be almost operator free if it was designed in the right way.
through the RPA, one excellent thing we could do in the past, like thermocouple data from the tire and RPA simulation. The same temperature data and the compound curing at that temperature and seeing whether it is getting over curing, and thereby cure cycle optimization is possible, and that could be done in the earlier company where I worked by taking the thermocouple data from the tire, and you feed the data in the RPA equipment and you do the temperature study, and you see whether your compound is getting over cured or under cured. And in that way, you can do the cure simulation. That means whether you are giving extra cure that you can predict to the RPA equipment from the thermocouple data.
Yeah.
So this is a huge cost saving in terms of if you are able to save the cure cycle by some minute, then it's a huge saving to the company.
Raj, you'd like to add any points?
Yeah, certainly, because RP is a very exciting topic, and it is one of the one of the wonderful rheometers, I would say. Like Dr. Brendan and Dr. Krish also highlighted how it would be useful, and even Dr. Samar was also highlighting some application which can be simulated on the RPA. So if you see that, yes, we can certainly accept that today, even in the industries, I'm talking about even the small and medium scale industries in across the globe. Mooney is always the starting point. So today the materials are actually rubber materials are selected based on the Mooney viscosity range, and people used to first step would be always the Mooney, and then comes the MDR. So it's a moving gyrometer. Earlier it's a oscillating ODR was there, and ODR was replaced by MDR. And MDR is, as you know, it's mainly used to understand the curing behavior, because very often we would be doing only isothermal Q test and try to get the characteristics, quality control parameters like minimum torque, maximum torque, elastic torque, and then you have the conversion times like TC10, TC90. Those are basically a standard quality control parameter that is being followed across the industries, rubber industries. I mean, so, but what is happening is that there are many times is that you see that you have the body, you have selected the particular rubber material, and that material is matching with the body specification, and also many times your Q cycles also would be within the tolerance range. But still, those materials when it goes to the production, there might be the issues. So the processing people might have complained that they have the problem with the particular rubber compound. So that is clearly unaddressed by these kind of equipments. If you have the standard body and MDR, many times you may not be able to address these issues, because as per your quality requirement, it is you are meeting your quality requirement, but still you are facing this issue. That's where RP would be the excellent tool, because here you can do complete rheological characterization. It is not just limited to certain passive shear rate or frequency, because it's offer a complete flexibility, so you can perform a complete viscoelastic characterization, so you can capture those effect of various components. Like I would categorically say that, so you can utilize your RPA for the incoming green rubber. So you have the rubber materials, probably you must be sourcing it from same suppliers or from a different suppliers. And okay, like suppose you are taking a EBDM from one particular supplier, but the batches are different, right? So you have your body unit within the range. So your quality control people would qualify that particular EBDM grade, but then comes to the processing times or even in the mixing time, there could be a challenges. But we don't know what would be the reason. But if you take that particular ABDM number, that the good one and the problematic sample, and you can analyze it on the RPA, you can test that, you can get the better idea what would be the possible difference between these two materials. So the RPA is offering that possibility. That is one of the key advantages. Now coming to rubber compound, like Dr. Krish was highlighting about the filler dispersion, right? So that is something very important. So we would definitely to achieve the desired mechanical properties, the filler play the important role that we all of us know. But how to check that one? There are various approaches there, but even you can use the RPA also here. How good your rubber compound, because most of the time these are batch process. So every batches are we maintain the consistency in the batches. So that way you can use the RPA. And you can use the curing studies. So you can use your RPA as a MDR. So you can still do complete curing and try to get the characteristic quality control parameter like TC10, TC90, and SL, I mean minimum torque, maximum torque. And further, it also allows you to perform the Q kinetics also, right? So then now you have a cured compound. Now what you can do is you have a cooling mechanism which can cool down the dye. So now you have a cured compound. On that, you can easily do a quick frequency sweep test, or you can do a quick strain sweep test that give the idea about the viscoelastic of your property of your cured sample. So this is overall it's a very effective instruments, and you can give you can utilize that RPA for your standard quality control requirement as well as your enhanced quality control for incoming material, and as well as you have used it for your rubber compound and the cured materials. Okay, so that's the value addition what you're getting. Now the next question would be is that okay, like I'm being a small and medium rubber industries, I'm investing on the Moody because that is my primary equipment, and I have to invest for my MDR. So what is this? Because we all know that RPAs are very expensive. Like Dr. Brennan explained, it is about 150K to, depending on the complication, your price would be more than 150,000 USD, right? So it's an expensive equipment. So how to do that? So this is where some of the equipment like key instruments, we have a flexibility because we many time understand that industry want to go for initially for an MDR. But if you look at the operational wise or diagnostic wise, between the MDR and the RPA, there is no difference. MDR also applying the same oscillatory stress, but your frequencies are restricted, your strains are restricted. When it comes to RPA, the motor doesn't have any restriction. You can apply the stress or strain to the various degree of angle. Also, you can apply the different frequency. So what we are offering is that you have like a MDR. So you have the RPA Flex, for example, TA is offering a model which give you the MDR functionality, but the hardware is inbuilt already to convert that MDR as an RPA Flex. So here, as compared to traditional MDR cost, you are going to invest 25 to 30% on the higher side, but you get the equipment which can be later upgraded to full-fledged RPA. So as and when you have the requirement that you want to do an enhanced quality control, or you want to do a little bit of process troubleshooting or things, you can convert your existing MDR to the full-fledged RPA. So that's a good part actually. So you don't need to invest one more time for a brand new equipment for RPA, but you can convert your existing MDR to the RPA. So that's the possibilities also there. So that's what I want to convey from my side.
Thank you, Raj. Yes, I would like to move the subject to the test repeatability. Okay, those issues. Okay, so Chris, I'd like to address that.
Yes, I would. In fact, and I think Brendan also started to introduce this, right? We think about testing a sample like this. How much material are we actually testing, right? It's this little bit of rubber. If you've got a 500 kilogram batch of rubber, and if you've ever heard one of these drop, you can almost feel it, right? And it drops and goes on the sheeter. It might take 5-6 minutes for it to pass along the sheeter to where it's going next. It's that much rubber. So the question is now about sampling, right? Where do we sample? How much rubber do we sample? Because there's two things, right? There's repeatability of the test equipment itself, and then there's variability of the rubber compound. And sometimes people get these two things confused. And so I do have a slide that I put together just to kind of convince people that these are separate things. So tensile testing, I showed you this one here, right? This one, I'm not going to tell you whose rubber sheet this is, but it is let's say, I have to be careful. It's a top 10 tire company. And what you can see is there's only 3 specimens cut out of it. So one company thinks it's okay to test 3 repeats of a tensile test. I'm showing you 5 here. So if you test 5 specimens and you have some kind of control material and you have something new, in this case, we intentionally tried to make a poor carbon black dispersion. Now, this is not dispersion in the micro dispersion sense I was talking about for the RPA. RPA is very useful for telling you about the micro dispersion. This is macro dispersion, right? This is something that the dispergrator can see, right? Really big micron-sized agglomerates. And what you'll see is that the tensile strength for 5 repeats, 4 of the specimens are very similar to each other. And then there's one strange one, right? 17.9, 19.5, and then comes a 12.9. And so what do we do in the rubber industry? Well, depends. Sometimes people say, oh, that must have been a bad result. Let's just kick that one out. Or maybe they'll be a little bit more objective about it and they'll say, okay, let's remove the low one and the high one, and then we just average the 3 in the middle. But no matter what, you've gotten rid of that 12.9. But if you actually test 50 repeats of that rubber compound, what you see is that 12.9 is real. It's just on one end of the distribution. And so this comes to reliability, right? You know, how many times out of 100,000 specimens will one fail below some threshold, right? And so it comes to statistics. And it turns out the flaws that are inside rubber that come from things like undispersed carbon black, et cetera, they have a distribution. And you don't know about the distribution unless you keep testing. And I actually like the idea of a big block of material, because there's kind of 2 ways to look at this. One is you could test many specimens, or you could make a giant tensile specimen and you could test that. And if there's a big undispersed bit of carbon black in there, it will fail at that biggest problem. And so there's kind of a different philosophy about testing and material uniformity. But you can see that if you compare the good dispersion to the poor dispersion, the strength goes down. It goes down from about an average of 21 megapascal to, let's say, 19 megapascal. So there's about a 2 megapascal drop. Maybe some people think that's okay. However, there's a tail in the distribution from the poor dispersion material where you might end up with a 12 megapascal or a 13 megapascal, because you might just happen to grab a specimen that has a really big agglomerate of undispersed filler right in the middle of the tensile specimen when you pull on it. And so I guess, going back to Brendan's point about material uniformity, I think strength measurements show this the most, right? Because any failure measurement is going to tend to emphasize this. But maybe one of the reasons to err on the side of still keeping the rebound test around is because it's a bigger chunk of rubber, right? Where your typical DMA is just a little bit of rubber like this. And so those are the other considerations. And so when people, what I hope people will come away from this slide is, why do we do 5 repeats in a tensile test? It's not because your Instron or your MTS has error that you need to repeat the measurement over and over again. It's because your material has real variability within it that we need to tease out. And so people might say, well, 50, why would I ever test 50 repeats? Well, but you are willing to buy a dispergrator and microscope and really investigate rubber to try to figure out where these undispersed things are and how many undispersed things there are inside rubber. Maybe a better test is just to do a really well defined tensile distribution where you test enough specimens that you can see some of those tails in the distribution. So what I would say is, if you see a low number in your 5 repeats, it might be telling you something real about your material. But I think most people would just think, oh, something must have happened wrong in that test. Maybe it broke in the grip, or it had a nick in it from the die or something else. But possibly and probably there's something real about the material that one data point is telling you. If you continue to test, what you'll realize is that 12.9 is in fact part of the distribution. You just happen to catch, you were actually lucky that you caught it in the first 5 specimens. So, but I think that's why we have to do gauge R&R, right? People mention operators and how important the operators are. So you've got the test variability, and then you've got the operator variability. And what I would say is sometimes people forget about the inherent material variability. And when it comes to things like failure tests, like crack growth or tensile strength or wear, any of those tests, definitely the variability is much higher because of flaws within the material and sampling. If I happen to take a very small piece of rubber, maybe there's a giant agglomerate of carbon black here, I just don't know it because I only test this little tiny bit of rubber. Now, am I going to convince people to switch from 5 to 50? I don't think so.
Yeah.
And you know, but if you wanted to predict what's happening in your material, I had a project as a consultant with a company that makes little O-rings, and these O-rings go into fuel injectors, and they were finding out that an O-ring would fail at a much higher rate than they could predict, and it really came down to sampling, right? They weren't sampling enough of the rubber compound to find out that every now and then there was a little bit of undispersed filler that then would cause, and if you happen to show up just by luck, happens to show up one of those in an O-ring, and the person finds out when they drive their car maybe 100 miles down the road, and then they lose their fuel injector. And so, yeah, so these things are important when you're starting to think about reliability of rubber, not just the average property. Now I've done this test where you do 5 and then you do 50. The first 5 and sometimes the first 3 will get the average properties very quickly. You will get the middle, the median, and the mean pretty quickly within the first 5. What you always miss is the highs and the lows when you only do 5.
Brenda, would you like to add?
Oh yeah, this is a huge topic when you're dealing with a heterogeneous material like compounded rubber with all the inherent variability. You know, from the lab perspective, I find there are basically, I guess, 6 things, which is a lot to to address the reliability and consistency issue. First, I'll just go through them, hit them. Weigh up tolerances. The technicians that weigh up the material, they have to be very cognizant or very aware of the tolerances that are permissible and have to stick with it. So the tolerances are crucial. The calibration of all the equipment is very important, and as part of one of the things that ISO, QS, TS all require is calibration procedures, documented calibration procedures, and all the records that go along with that. And the shortcoming of those standards is you have to document, but it doesn't really go into detail on the frequency with which calibrations have to be done. So weigh up, calibration, equipment maintenance is crucial. Again, proactive equipment maintenance procedures. The molds and the dyes, Chris had mentioned this one. That's a big area. I remember a lot of molds for rubber preparing tensile sheets, for example, were chrome plated, and you got a very, very high quality specimen. Now, chrome plating of molds is a cost involved in that. So today they're mostly all just steel, polished steel. But good quality molds and then good quality dyes. Small nicks on a tensile dye can create a lot of anomalies in the data. So the dyes and the molds are crucial. One of my hot buttons is lab hygiene. Clean labs are efficient labs. Dirty labs are, you're gonna get what you get. So, and lab hygiene and environmental controls in the lab will all contribute towards getting that, minimizing the variability. And then tracking. And this has been an issue. Lab information management systems, LIMS systems, are very good at flagging out drifts or trends. If we get an anomaly in a tensile tester, the data tends to start drifting off. The a good, well-managed LIMS system will help flag out some of those issues that might come up periodically, which inevitably were going to come up. And of all the LIMS systems that I've seen, probably Alpha Technologies have probably got the best. You know, they had the Eclipse system, which was an old D-based, 2-based data management system. They brought in a new one recently called Enterprise, which I've not had the chance to use, but I found Eclipse was probably the best commercial lab management system that was out there. And there was modules in there that you could look at trend data and see if there was some anomalies. But again, coming back to addressing this issue on variability, the way up of the samples is crucial. If there's a mistake there, well, that's going to propagate right down through the system. Equipment calibration, maintenance, maintaining the molds and dies, and then lab hygiene. All those things are really important to, again, address this issue. Given that we're dealing with, as Chris, you put very well, a heterogeneous system with a lot of variability, and then one flaw can really create issues in terms of the data interpretation. So that's how I kind of saw it. Having worked through these issues, getting the certifications in labs from like government agencies and so on. These are sort of things that have to be addressed to, again, in turn address this issue on variability, sample variability, and sample reliability. So that's been my experience.
Samar would like to.
Yeah. In this case, as Brendan has said about the certification or the accreditation, if the laboratory gets accreditation like ISO 17025 standard, this standard is excellent. It gives focus on technical aspect as well as management aspect. And technical aspect says about the man, method, measurement, environment, and also about the material, standard material, CRMs or SRMs, and competence. Basically, the competence of the people, that is very important. First, you select the people on the basis of their competence required, and then you also monitor the competence while working in the laboratory. You see the standard of the people by getting the competence monitoring, and you authorize them for particular job and also monitor them, how they are doing. And environment control, equipment calibration, equipment maintenance, then your method, you have to use the standard national or international method and also up-to-date method. Then sample register, how you are controlling the sample which is coming to the laboratory and up to disposition, when the test started, when test completed, when the report was sent, and when it was disposed. Then comes the quality assurance. Quality assurance by certified reference material, retesting, replicate testing, intermediate check, blind sample, then using different alternate equipment. So many steps are there, as well as ILC, interlaboratory correlation, and the proficiency testing, PT. So all these things are very, very good for keeping the less variability, because we are dealing with a very heterogeneous material. And if we maintain these systems or follow these standards, definitely we can get some good quality.
Thank you, Dr. Samar. Guys, I'd like to, actually, Dr. Brendan has mentioned, start about data management. Can you give some insights about how, you do tests, you get a lot of data, and particularly, okay, big companies have a system is there, but small companies may not have the proper systems. Brendan would like to touch, start with how to manage the data developed, okay, and how to interpret the data at the same time using the data for the future product developments or future compound developments. Can you share your insights on it, please?
Oh, yeah, well, yeah, I've seen several systems. The majors like Goodyear, Michelin, I suspect Bridgestone as well. that have their own internal developed LIMS systems. The smaller companies don't have that resource of programmers to build a LIMS system. So there's some commercial ones available. And like I said, the one I'm familiar with, the Alpha Technologies Eclipse, I thought was an excellent system, very, very effective. Not only would the compounder or engineer input the compounds that they want to investigate into Eclipse, but the technician can then take that information, they'll get the weigh-up sheets, the batch weights. Then when the testing is conducted on the compounds, it's automatically captured in the Eclipse database, and tensile testers are all hooked in, the rheometers, Moonies, and so on, and other specialized equipment can also be hooked in there with the right interface. So that's been very, very good. Now, I think as I mentioned, some of you might be more familiar with this, but Eclipse was an old DBase 2 system that is basically obsolete, had some security issues, and it was replaced by Enterprise, which I've not had the chance. I've not had a chance to use it, but it's essentially an updated Eclipse for all practical purposes. And you can put up to maybe 15 compounds or 20 compounds. Well, in fact, I think with the Enterprise, it's unlimited the number of compounds that can go into a specific study. But the big advantage is the data capture. So it automatically, the data from an MDR rheometer, for example, or the RPA would be automatically captured by Eclipse, and then the compounder can look or Enterprise. The compounder can look at the data that's been generated real time at his desk, which could be remote from the lab, and so on. So that's fairly effective. The beauty about LIMS, you avoid a lot of issues like data entry, typos, that sort of thing when the technician's reporting the data back to the engineer. So LIMS is important, and a good LIMS system will also allow you going forward into the future to build those neural networks that we talked about. And I've always argued that neural networks are not a replacement for doing compound development work in the lab. It's an additional tool to improve the quality of the work that's coming out of the lab. And that's the rhetoric, the justification is quality improvement. I don't think these modeling tools that are emerging will ever replace the work done in the lab itself. We still need to do that, but it'll certainly improve the quality of the work that's going in. And the other thing, by having well-documented data, which Eclipse or Enterprise will facilitate, is that the decision-making will be better. So any subsequent lab work will be more focused on what the objective is for the particular program. So it'll improve the quality from that perspective, better focused data. And then, by having those more effective databases, then that'll allow faster decision making. And again, the ideal is to be able to mimic what the pharmaceutical industry has done. And for example, the COVID-19 vaccine development, which was again phenomenal, the way they did that so fast on such high quality work, that's what we should be trying to achieve. And one other thing, probably along that line, and it's more of a data dump, is documentation. A good LIMS system will facilitate documentation, and that's always been an issue that the development staff have struggled with, is documenting their work. A good LIMS system will help facilitate that. Documentation is extremely important from that perspective. So, but I'm sure there's other LIMS systems that are out there that I've not had a chance to work with them, but they certainly a necessity in the lab today. In today's labs, is essential.
Chris, you have any other additional input?
Those were excellent points. I've experienced both ends of the spectrum where you have really good lab management software and processes, and then on the other extreme where it's every man for himself, or every person, every man, woman, and person for themselves, and it's really inefficient when you're getting data off every piece of equipment in the rubber lab is just put into a folder, and then it's up to the engineer or scientist then to process that information and come to decision making. They spend all their time plotting and putting things in tables and generating. And then on the other extreme, you have these automated systems where everything is in one system, and even the graphing. One of the blessings, I think, in my view, to the tire and rubber industry has been the influx of really sharp scientists and engineers who have no problem with scripting everything in Python. These folks are amazing, and they have really improved the efficiency of what we do as engineers. But you have to have some place and some way to organize all those results in such a way that it's easy to write a quick script to pull everything out, plot it up, and make a decision. Did that new compound work? Did that new raw material work, et cetera? I saw a really great example of this where we were sitting in the tech center and we were accessing compound data from 2 plants, pulling all that in, looking at it, and realizing that there were some seasonal drifts of silica silane reactivity in compounding of a tread compound. They had noticed that rolling resistance had some variation, and they were trying to track down why it was that the tires produced had some rolling resistance variation. And what it came back to was silanization, the presence of humidity in the summertime in the locations where the plants were located was leading to more silanization and lower rolling resistance in those times, and then opposite in other times of the year. And the only way that this was discovered was by having a really well-designed, well-implemented LIMS system that allowed the folks in the tech center to sort of troubleshoot this by pulling in the data, replotting it, reanalyzing it, looking at trends, all while sitting in the offices and not having to venture down to the plants and trying to pull that data off of an instrument, or in some cases, maybe in other situations where they didn't have that capability, the data just didn't even exist, right? In some plants to be able to do that. So yeah, so I can testify to the power of that. I like where Brendan's going, where this machine learning and this AI, it's definitely going to be coming. And the other thing about having this nice LIM system is archiving, right? If you've got a really good LIM system, that includes at the front end, the compounder is deciding what raw materials go in, and we'll have a lot number for each raw material that goes in. If you're trying a new raw material from a different supplier, it's identified. All of that goes in, the formulations put in there, and then as it goes through the rubber lab, anything to document about the mixing is there. If you wanted to look at a torque curve from your mixer, you can click on and you can see the torque curve, and then you get the cure curves, you get all the final cured properties. And now if you want to go back and data mine and figure out if something was missed, or to get a sort of a leg up on product development, and by doing big data, some sort of bigger picture view of everything that's been done. The one thing that's common about rubber labs is we have tons of data, right? I mean, it's a sea of data, but if it's well organized and well documented, it's also a wealth of information that you don't have to reinvent things all the time. Maybe when you're developing a new compound, instead of trying to go forward, sometimes you should go back, and maybe you miss something, but you can't do that if you don't have everything in one place in such a way that you can go back and easily take a look at it without the person responsible being involved, right? We have turnover like every industry. Someone moves on from a project, moves on to another project. And a well-designed LIM system should be independent of that, so that a new compounder who's just coming in to the company should be able to go in and very cleanly and clearly dig back into data, and then use that as a stepping stone to developing something for a new application. So I'm all in favor of that.
Okay, Chris. Raj, you'd like to add you must have your own system as well, I guess.
Yes, we do have that similar setup actually. But answering to your first question, um, I've seen many times these small and medium enterprises, my industries people, they often ignore this database management. So they just want to buy the instrument, but they don't. And I mean, I would say it is because of lack of awareness about the data management. As like Chris clearly highlighted, how it be beneficial. The basic architect is very simple. So we have that compound. So the compound, under the compound, you have the complete recipe. And then from that, you can do all your data will be saved. Like you can dump it whenever you may do any modification with recipes that you can enter into the data. And secondly, whatever the test what you're doing, both the rheological, physical, hardness test or thermal test, whatever is there, everything would be there. And today, all this software database are giving you a trend analysis. So what you can do is you can retrieve all your historical data for the particular compound, and then you can see how the trend of those, how this particular compound is evolved during the past, and you can do how many times it failed. So you can easily come to the point why that particular situation, like Chris was explaining about the rolling resistant application, how it failed, but we can easily able to find the reason behind that. Okay, so that is the key advantage. And many small and industries or medium scale industries are ignoring this part, but for me, I would say that is something is very important. They need to invest for that. So the data management is something is very crucial, and that would save a lot of time. Obviously, for time is money. So you can easily do this kind of trend analysis and come to a faster conclusion, or you give a right direction. How do you proceed further? Actually, so that from my side.
Thank you, Raj. I think the one last point I want to address in this session is the maintenance and calibration issues of instruments. Okay, and as a user point of view, Chris, what is your experience on that? Like a quick way of, we're going to wrap it up this session soon. Yeah, so
I think following the standards, right? And I think the previous discussions about having quality standards in the lab is key, because all of that is wrapped into that. We suffer from something I used to call tragedy of the commons, right? You have all these users of the equipment, but no one person who has ownership. So I think one of the best things you can do, and this is where rubber lab management has maybe passed into some dangerous territory, right? You're always trying to cut back and make do with fewer people. And so it used to be that technicians had responsibility for certain pieces of equipment, and that with that ownership comes some of that responsibility to make sure that things are done. And I think sometimes things can slip without that. So it goes back to the discussion earlier about taking care to keep staff up, and don't always see the rubber lab as an expense, because what would happen if you have a recall like Brendan suggested, and now you need that data, or you're trying to develop a product, and somehow you never want to have in the product developer's mind, is that data right, or is that instrument calibrated? You never want that thought to be blocking their creative and engineering judgment, right? So I think it has a lot of value. And I think having ownership where people know that this is the instrument I'm responsible for. I'm going to run standards. I'm going to calibrate. I'm going to follow the procedures.
Brendan, would you like to add anything on this?
Oh yeah, that's crucial. The well-managed lab always assign the technicians individual items of equipment that they're responsible for, and both from calibration and maintenance. And ExxonMobil, they did a great job in that area. I thought it's very effective, and I find one of the key things in getting the government agencies certifications when I was in the lab was, again, making the technicians responsible for the equipment. And without exception, they all stepped up to that responsibility, without exception. They like that. And that way you have the ownership, and it's theirs. And that was a very effective way of doing it. So the ownership is, could not agree more.
Raj, what is your experience? Raj, how is your experience with the customers, with the maintenance and calibration?
I can say here, Prem, actually, calibration people usually performing it, okay, because of their regulatory confirmation, because most of these testings or QC labs are, enable accreditation or some other accreditations by the agencies. So they have to do this periodic calibration. But what is I'm seeing it that they don't have the proper maintenance of the equipment. So very often they are ignoring this maintenance provided by the suppliers. I mean, I'm talking about like instrument suppliers. We do have a service engineer who can go to the instruments and then they do certain maintenance, which they don't, opt to go for because there is a specific charge involved for that. I can understand they try to save that, but I would highly recommend that this maintenance is also very, very important because calibration is just you are just verifying. Some labs I have seen that just restrict their scope very much to verification. They don't do the calibration until unless the verification fails. For example, like I could say like a DSC or a TGA, we have certain list of standards which they supplied along with the instruments. So they would do verification with that by running the particular certified standards. But if the values are coming within the range, they qualify it and they don't do the calibration. If it fails, they would also further do the calibration. But what they are lacking is a maintenance. In an instrument, it's not only about a calibration, how you are accurately measuring the data, but there should be certain maintenance should be periodically done on the equipment. Otherwise, over the years, probably if you see in a normal span of any analytical equipment, I would say it's 7 to 10 years. That is very common. I hope my other panelists also accept that fact. So if you want to utilize your investment of that equipment for 7 to 10 years, the maintenance is something is very, very important. And I would highly encourage that any analytical people who are using the analytical equipment would definitely need a proper and periodic maintenance. And that need to be properly discussed with the suppliers, instrument suppliers.
Thank you, Raj. Guys, I want to continue this session much more longer. I think we still can discuss longer, but we may have another session some other time. I thank you all for joining the session today. Before I end this, panel discussion, I'd like to request you guys to give a final remarks, 2 minutes of remarks, final remarks on the good and bad practice rubber testing. Chris, you go with first, man.
Yeah, thanks for organizing this, and I learned quite a bit too, so that's always a good sign of a good conversation. And maybe that is my take home is to have conversations about these things, right? Sometimes we get into habits, and that's true of rubber testing. And so I think Rajganesh just said, let's have conversations with instrument suppliers when they recommend that we should use seals or replace seals on a regular basis in an RPA. We should listen to that. We should have conversations with each other about if we add a new test, do we really need to keep this old test? Maybe the answer is yes, we do need to keep this old test, or maybe not. Maybe we can become more efficient. But I guess my take home is in an industry that's been around for over 100 years, and testing that's evolved across that 100 years. Maybe my biggest take home is let's not think that everything is set in stone. Let's have conversations. Let's continue these kind of discussions with each other. Let's enlist technicians instead of seeing technicians as just someone that you give some requirements to and some orders to. That you have conversations with technicians. You give them ownership of the equipment, responsibility. You have open up dialogues across the organization, and that includes with management, so that management doesn't just see the rubber lab as a cost. They see the value, and so some of that's about messaging, right? We have to do better about how valuable the data is and all the decisions that get made. That when you roll out a new product, that rubber lab was key and critical to that decision and that success. And so yeah, I think let's have conversations across the value chain of rubber testing.
Thank you, Chris. Samar, yeah.
Yeah. So what Raj was saying, not maintaining the AMC, this is a dangerous thing. If you don't maintain the AMC, and it is not spending, it is an investment. You know, you have invested a lot for that particular equipment. And if you are only doing intermediate check by some standard material, it will not be the right one. You must know from them, and you depend on them to increase the life of the equipment. Otherwise, your equipment may get down anytime.
Thank you so much. Raj? Yeah.
Yeah, my take is first of all, I would definitely, it was a very wonderful discussion with among the panelists. I mean, I also learned a lot of things, and I could clearly see what are the challenges that we have in terms of rubber testing. So, like we said, how about the material variabilities? So, how much we focus on the instrument side, we also need to address those issues like a variability which is coming from the, especially, from the sample side as well as from the operator side. So we, from the instrument supplier, I definitely take this point. I do discuss with my product management back in our headquarters, see how we as a instrument supplier can address those issues and minimize those variability. That is one takeaway from my side. And then second thing is, like I said, we have created a lot of awareness today. I see definitely this discussion has clearly highlighted the importance of data management, how important, how crucial that is one, and how important for sophisticated equipment. So because many times people are, I've seen in the, especially in the medium scale industries, what to invest. Should I go for a classical equipment like Moody or ODR? Because still we used to get the inquiry for ODR. I'm very surprised because some people still want to invest the ODR, which is outdated technology today. So because industries we move to FDR and people are moving towards RPA, but still in India, I see many times, customers are inquiring about ODR technology. So, but this kind of discussion would definitely create awareness, and I think that is the key objective of our panel discussion. So I will be very glad to be part of this session. And thanks for this wonderful opportunity.
Thank you, Raj. Brendan, final to you.
Oh, okay, yeah. Well, I thought the discussion was excellent. A lot of perspectives, and what impressed me was how close we are. Our perspectives are very, very similar. We've all encountered the same issues, so there's a very high degree of consistency in the views that were expressed. I think there are probably just three things, and it's more looking more into the future, but and we didn't really get a chance to drill into it. But one is predictive testing. One of the managers who have to fund these labs, what are they going to get for it? Predictive testing has to be one element there, which would be a good topic for a future, I think. Automation is a big one.
Yes.
And
Yes.
to get the throughput, to get the output up higher, it's a productivity issue, automation. And then the modeling area. And modeling, I don't see modeling replacing the labs, more as supplementing or improving the quality of the work coming out and the quality of the decision making that the engineers take on the basis of the data that's coming. So it's an additional tool to improve the quality of the decision making. But they're the three things: predictive testing, automation, and modeling, and all geared towards, again, improving the quality of the decision making that that results from the data coming out of the lab. So, but again, an excellent conversation, discussion. I really enjoyed it. Hey, and Param, thanks for organizing this. It's great, absolutely great.
Okay, guys, thank you very much. Thank you very much. It's really wonderful discussion, and I think that audience benefited from this session with various issues. I think I take the input from the Brendan about the other issues to be covered, maybe some other time, okay, in the future. Okay, actually, I want to ask on the laboratory automation, is it possible or not? Maybe we can put the discussion some other time, some other day. Okay, once again, Brendan, Chris, Samar, Raj, thank you very much. Thank you very much for joining this session today. Okay, thank you. Yeah, bye bye for now.
Bye.
Okay.
Thank you.
We'll be in touch.
Thank you, Brendan. Thank you. Thank you, Raj.
Thanks, everyone. Cheers.
Okay, guys, that's the end of the presentation, the panel discussion on the rubber testing, good and bad practices. I'm really hoping that you find it useful. And so if you like to watch this session again, you can always go back to the, our, on YouTube Technology channel, check it out. For repetition of this panel discussion, and which is very useful from all the panelists, Brendan, Chris, Samar, and as well as Raj. They really gave a good input. Okay, if you have any comments, suggestions, feedback on this program, please write to me. I'm happy to take your input and keep on improving our Rubber Industry NewsHour program. I hope to see you in the next episode. Thank you all. Bye bye for now.